Hello and welcome to AQA Chemistry Paper 2, 2018, higher tiers. This is part 3. Okay, so moving on to question 6. This question is about polymers. Polyesters are produced when monomers join together and lose a small molecule. Name the small molecule lost. It's actually water. So it's common or garden, water. Okay, that always happens. They always produce water, those reactions, polymerization. Okay, polypropylene is produced from propene. Okay, complete the structure of polypropylene in the equation. Okay, so we've got N, this one that says complete. So we need to do that. One's actually easier than it sounds or looks, because it's exactly the same molecule. It's just got these arms outside the bracket because it's poly. I need to do that as well. Also, yeah, double bond goes because the double bond opens up to join it to the next one. Okay, so that's actually quite easy, 3 marks. It's the same molecule. We just need to remember the N and that double bond to open up. Okay. Carpets are made from polypropylene, wool from sheep, or a mixture of it's really hard to say that word, polypropylene and wool. Polypropylene wears out more slowly than wool. A mixture of polypropylene and wool to make carpets is more sustainable than using just polypropylene or just wool. So often polypropylene comes from oil. Okay, so polymers often, other plastics come from oil, so they are non-renewable. So polypropylene, I can't say, don't worry, we don't have to say it either, you just have to write it and it's spelled there. Polypropylene comes from a non-renewable source. It's usually oil. Most plastics do. Okay. Non-renewable source. And also it's not biodegradable. Ooh, biodegradable. Not biodegradable. So wool is sustainable but wears out faster. So you've got benefits and drawbacks of each one. So so a mix would last a little longer and be part sustainable. Part sustainable. Wool does last quite a long time, doesn't it? And you've got wool jumpers that are quite old. So maybe mainly wool. So I think wool gems are more expensive as well. And that's not part of it's no reference to cost. Yeah, I was gonna say that's not part of so don't talk about cost there. Try to avoid it. Okay, polymer fibers to uniforms. Table 3 shows some properties of 2 polymer fibers. We've got property, we've got polymer fibers. It's got polypropylene and polyester. So density in grams per centimeter cubed, and you've got melting point in Celsius, flame resistance, and water absorption. So you've got polymer fiber property, so we've got polypropylene density 0.9, polyester 1.38, melting point 1.6. So it's firefighter uniform. So have a look at what the property is. Okay, so obviously they need to withstand a high temperature, don't they? Evaluate the suitability of polypropylene and polyester for firefighter uniforms. Okay, so evaluate, that means you have to talk about both of them. Okay, so we have advantages and disadvantages of each one. So give us some space here. Okay, so let's have a look. So we've got advantages of polyester. We'll go for first. It's got the temperature one. So advantages of polyester. Okay, so that's the main points, isn't it? So we've got flame resistance. We need that for firefighter. Melting point. The advantage of polyester. So better flame resistance. Higher melting point. Higher melting point. Okay, obviously, so it's not going to melt, hopefully. So yeah, no damage, so less damage to uniform, obviously, onto the person. Okay, so also disadvantage of it though. Polyester. So yeah, it's higher density. I noticed that. So higher density, so uniform's heavy. So uniform's heavy. So also absorbs water. It could be a good or a bad thing. So uniform, so they're using water, so uniform becomes heavy. Might be better move about as much. Okay, so let's have so yeah, that's what I would choose. So it's evaluate the suitability of polypropylene and obviously with the other way around, if we did make some bit more space. Okay, so polypropylene. Advantage, it's lighter, isn't it? So lighter uniform does not absorb water. Lots of marks to be gained on this quite easily. Anything is justified, it says. So anything you can justify. So but the water can be good or bad. Okay, so the only thing that's good really about polypropylene. Okay, and also disadvantage. Low flame resistance and lower melting point. Okay, that's nice and easy. Okay, actually, you get quite an easy thing to talk about there for firefighters. Number 7. Older cars are tested each year to measure the amount of pollutants contained in exhaust fumes. Table 4 shows the maximum allowed percentages of exhaust pollutants for petrol cars. So age of car in years 1624 through 16. Maximum allowed percentage. Carbon monoxide 0.3, 0.2. So the newer the car, the less they allow. Unburned hydrocarbons, the same. Explain how carbon monoxide is produced when petrol is burned in car engines. Because remember, carbon monoxide is caused by incomplete combustion. Incomplete combustion. So it's when hydrocarbons are burned, any hydrocarbons are burned with insufficient oxygen. are burned with insufficient, so that means not enough. Insufficient oxygen. You get carbon monoxide. 7.2 suggests 2 reasons why the maximum allowed percentage of carbon monoxide has been decreased for newer cars. Okay, so carbon monoxide, what's known as toxic. So yeah, actually you can kill people in high enough amounts. Okay, so and I would say for newer cars because improved engine technology. So we don't have to emit that anymore. Okay. 7.3. Give one reason for having a maximum allowed percentage of unburned hydrocarbons and exhaust fumes. So you could say to reduce health problems, because that's sort of soot and smoke. Okay. So 7.4. Only one mark. Just that one. So describe how oxides of nitrogen are produced when petrol is burned in car engines. Interesting, because hydrocarbons don't have nitrogen themselves, do they? So it's from the atmosphere. So nitrogen from the atmosphere. Okay, reacts with oxygen, also in the atmosphere, at a high temperature. It would normally react because temperature wouldn't be high enough. Okay. Nitrogen dioxide is an oxide of nitrogen. Nitrogen dioxide, NO2, reacts to produce nitrogen and oxygen in catalytic converters. Complete the equation for this reaction. The equation should be balanced. So let's put what we know. So we've got O2 and N2. Okay, so it's always diatomic. So we need 2 in front of this. So 2 and 2, 2 nitrogens, 2, and so we need to put 2 in front of that. Because if you multiply 2 by O2, it becomes 4, 2 by 4. So it's actually done. That's nice and easy, that one. 7.6. Give 2 effects of atmospheric pollution which are reduced by using catalytic converters. So number 1 is because you can get nitric acid rain. So acid rain. Okay, and also respiratory problems are reduced. Respiratory problems. Right. The catalyst and catalytic converters is a mixture of 3 elements. Let me just go back to this one. Acid rain. So you can actually, let me say what else you could mention here. Okay, you could actually allow things like damage to ecosystems. I mean, we've got 2 marks there. I'm just going to sort of talk about acid rain. I haven't forgotten. So damage to ecosystems, acid rain, or damage to buildings too. B-U-I-L. Buildings. Okay. So respiratory problems in humans. The other one is. Okay, let's go back to catalytic converters. The catalyst in catalytic converters is a mixture of 3 elements. Where in the periodic table are these elements most likely to occur? So most catalysts are metals actually occur in transition metals. Okay, so if you think about the Haber process, that's an iron catalyst. And that occurs in the middle or in the transition metals part. Okay. So So let me just make sure we put on humans. Yeah, just adding a little bit more to this because I'm going to move on to the next question. To just making sure it's complete. Okay, so what I'm going to do there is I'm going to stop the video there, and I'll do the next question in part 4. Thank you for listening. I'll see you in part 4.